So, in this lecture, we'll continue our discussion on case studies on platform as a service, infrastructure as a service, and software as a service. So, let us look at this case study. This is the case study which has been taken from the website of Amazon Web Service. So, this is not a hypothetical case study, it is the case study of a company called Chumbak. So, this company was founded in 2010. It is an India based company. So, it launched its retail business of selling apparel and home decor items. So increasingly, Chumbak sells more of its product via its web stores. So it has web stores and it is selling most of its product through that. With the web store generating more revenue, Chumbak needs to make sure that site continues to meet its two goals. So first is to deliver a great user experience, and the second is to encourage customer loyalty. The user experience depends heavily on the infrastructure behind the web store. So the infrastructure needs to scale easily, so site performance isn't compromised by sudden increase in traffic. It is also important for Chumbak to work with the cloud provider that offers pay as you grow service, because it is an upcoming company. Further, the Chumbak IT team also needs an infrastructure that is easy to work with. It could not afford an IT staff to be working on the infrastructure maintenance. Further, they cannot have developers spending more time on scaling the backend infrastructure. So let us see what this company did. How did it solve the problem? So Chumbak migrated to cloud services offered by Amazon Web Service. So Chumbak qualified for Amazon Web Service Activate, which provides startups with a low cost, easy to use cloud computing resources. So since Chumbak was a startup, it's already given in the problem statement. It could not. It wanted a service provider which could, offer pay per as you go model. Then Chumbak has increased its use of AWS service. This includes Amazon's relational database service, which the company uses to oversee time-consuming database administration tasks. So they have a lot of database to maintain since they're dealing with items selling apparels and home decor items. So of course they'll be having a lot of database, relational database. We're using Amazon's relational database service to maintain their database of the stock. So AWS also now offers services that help Chumbak improve their web store user experience. So it is not just that the database, Amazon Web Service also help them improve their web store. So the business uses AWS Lambda and Amazon Kinesis to capture and process web store click streams in real time. So basically, Amazon Lambda is an event-driven and serverless computing platform which is provided by Amazon. So in this kind of computing service, the code runs in response to the event and automatically manages the computing resources that are required by the code. And Amazon Kinesis basically is a data stream, is a scalable and a durable real-time data streaming service that can continuously capture gigabytes of data per second from hundreds and thousands of sources. So it was using both of these, Amazon Lambda and Amazon Kinesis, to capture and process web store click streams in real time. So when a web store visitor clicked on the product, it triggers AWS Lambda, which pushes the clickstream data into Amazon Kinesis. From there, the data goes into Amazon's DynamoDB database to find the visitor's product history. So what is the DynamoDB? So Amazon DynamoDB is a non-relational database, or this product history appears on the screen to the visitor with an imagery pulled from Amazon S3. So where was this history stored? It was stored in Amazon S3. Amazon S3 is an online cloud-based data storage infrastructure for storing and retrieving any amount of data. So with this discussion, let us look at the solution which came in. So Chumbak chose AWS because its technology and offering align more closely with with their IT strategy to utilize most of the services provided by Amazon. Chumbak can now dedicate its IT resources to development and avoid routine administration jobs with managed services like Amazon Relational Database. Also, twice a month, Chumbak runs a campaign to drive traffic to web store, providing visitors with special offers on Chumbak products. So if there is a sale, then what will happen? If they offer a 2-day sale, then during those days, there will be heavy traffic. Most of the users will be trying to purchase the items at discounted prices. So during that time, using auto scaling, the backend infrastructure to the web store running Amazon EC2 scales automatically to the level of the web store traffic. So that means it scales, and the firm does not have to bother about it. Further, AWS pay as you grow capability enables Chumbak to avoid the need to make large IT investment upfront. Finally, because of the success of web store on AWS, Chumbak is considering migrating its business critical enterprise resource planning system to AWS cloud. Let us look at another case study. So this case study is about a PayU group which operates in 16 countries across Asia, Central and Eastern Europe, Latin America and Middle East and Africa. So the Indian operation, so PayU India is one of the top 3 payment gateway providers in the country with more than 30% market share, comprising more than 300,000 merchants. So PayU India provides more than 70 online payment methods and aims to match the merchant needs with the way consumers shop and pay. So the business, which focus heavily on data analytics and data science, and it has more than 800 employees in India. So if we look at this, we come to know that PayU Group is a huge company. So let us look at their problem statement. To thrive in the market, the transformed PayU India operation needed to deliver reliable, responsive payment services. These services include payment gateways that enable merchants to take payment digitally from the consumer, and a planned product that would enable approved customers to consolidate multiple payments for day-to-day goods and services purchased online. So depending on the credit profile developed by PayU India, consumer would also be able to defer payments for a short period, say pay later, using options such as IMPS or NEFT, debit card, net banking, or through electronic wallet. The businesses needed to consolidate data from both the sides to maximize the use of information and to make profit. Okay, this should be 7. It's a mistake here. So this should be case study 7. We are continuing with the same case study. So the PayU India data science team calculated the business would need to scale up its existing infrastructure 4 folds while aggregating all data sources into a single database. With the new payment consolidation, the deferral product called Lazy Pay being prepared to launch, the business wanted to gain flexibility to run proofs of concept of various data products and services in a short time frame. So they had another product, Lazy Pay, which they wanted to launch. So PayU India concluded that it needed to adopt a full-featured cloud service to deliver its payment gateway and realize its potential as an online payment leader. Further, the cloud service provider it selected would also need to operate a data center in India. This is important to comply with the legislation which requires that consumers' data has to be retained in India and has to be operated with a minimum latency of 20 to 30 millisecond. So there are strict or stringent requirements that the data should be within the country, and also there is a very stringent requirement on the latency. Further, the selected provider would also need to, scale quickly to accommodate the unexpected event, such as the one which happened in 2016, where the government, decided to invalidate certain high denomination banknote, that is 500 rupee note. So during that time, the cashless transaction, these kind of services shooted up. There was a sudden spike in the number of users using such cashless transaction services. So let us look at the solution. PayU India formally decided to implement a cloud-based database and associated systems in AWS cloud near the end of 2015. Further, the data stored and managed in the database would be used to launch LazyPay, which would be accessible via a separate website. Then PayU India has also moved several production environments to AWS cloud, which the business uses to support its merchant and consumer. Further, it also created its own architecture in Amazon Web Service Asia Pacific region over a 6-week period. So during this time, PayU India engaged leading auditors to review AWS compliance and payment card industry data security standard, which is an important requirement and a necessary requirement for online payment providers. The Amazon Web Service now it has been certified since 2010. So it is PCI DSS certified in 2010. The company's auditor found Amazon Web Service met all the audit requirements. So the AWS infrastructure operates in Amazon's virtual private cloud to provide tiered security, since a VPN connects the environment with the co-located data center that continues to host dependent systems. Further, PayU India replicates database within AWS infrastructure, and a subset of the transactions are moved to Amazon's Redshift data warehouse. So where the queries are run to reconcile reports and payments and understand user behavior. The business is also evaluating Amazon's machine learning. So Amazon also provides machine learning as a service, the analytics, for the key function of determining whether the business should provide credit to Indian residents who do not have credit ratings, cards, or bank accounts. Let us look at case study 8. So Augusta is an electronic device company, and their focus for past few years was on developing Sanket and bringing accuracy to their algorithm. So what was Sanket? It is a device to record minute vibrations of heartbeat via the patient's thumb and generate an electronic signal that is sent to the Android or iOS app using Bluetooth. So the mobile app records these electronic signals and sends them to a function in the cloud, which converts these signals to an understandable pattern of ECG. The data collection and aggregation strategy was missing in the implementation. That is, how will it be collected and aggregated, and where it would be stored. So they have a parse-based implementation on which they store customers' profile and the PDF file of ECGs, while the raw data that produces ECG is not stored anywhere. The PDF files generated on phone app are uploaded in the parse. So if you look at that, they have this was a company which had a device which could be plugged on a on the user's thumb, and then it would collect the signals, which would ultimately then be converted to ECG. And the connection was through the mobile phone, which was either Android or Apple. So let us look at this. The What was the problem? The problem is that raw data from which the ECG is being deduced is discarded and is not kept anywhere. So that means the data which was being collected from the thumb of the user, that was being used to calculate to deduce the ECG, and then that data was being discarded. Since raw data is not pushed to the cloud, further analytics are not possible on the cloud, especially for historical review or predictive analysis. So further, the customer profile, apart from customer profile, no other information related to the device is available on the server side for processing. Right. So because the data is being discarded, and there is the to analyze that what kind of signal led to what kind of ECG, and what was the history based on which such ECGs are coming, nothing could be predicted. The information about ECG file is in parse, but no reporting tools are available for the same. Parse is being discontinued by Facebook, and Agatsa wants a more scalable platform on which to store data that can easily be used for analytics and reporting tools that can be fed to machine learning systems in future. So let us look at the solution. Here this is case study 8. There's a mistake here, again it should be 8 here. So let us look at this. The solution was evaluating ECG device capabilities. So if you see, Sanket is a custom device that currently has only Bluetooth, and it can only communicate with a Bluetooth enabled mobile phone, which has either Android or iOS, that is for Apple mobile phones. Then the ECG data packet is about 90 KB in size, with all 8 to 12 lead worth of data. That means the entire size is 90 KB. The user needs to hold the device up in his or her hand for up to 15 seconds to get the ECG. The data packets of the ECG is sent all at once to the cloud after the data of all the leads is collected. So the simplest solution was to collect all the data and send it to the cloud. So an important task at hand was to make iOS device talk to Azure IoT Hub. So what was done, and it could not connect as there is no IoT Hub SDK, software development kit for iOS. So basically a REST application program interface wrapper was created so that iOS device can connect to it for creating device identities and sending device to cloud messages. So basically a REST API was created. So then after making both Android and iOS device talk to Azure IoT Hub, a simple IoT Hub based backend was created as shown in the figure. So if you look at this, there is a notification hub, and Azure Web API sends notification. This notification hub also communicates with the mobile phone, which communicates with the Sanket ECG device. So this is the device which user will plug in the hand, and mobile phone is the device which the user will have. So and what do we have here? We have the storage of Azure. Then we have Azure's SQL DB, which is the non-relational database. So basically data is received from the device, which goes to if it is the Apple mobile phone, then via the REST API the data is transferred to the cloud. Then the job, so first that raw data is stored in the Azure. The first thing was that raw data was not being stored, so it is stored here. And then second is to calculate the ECG pattern over raw ECG data. which is then stored in the Azure's non-relational database. And then it goes to Power BI service, from where it goes to the Azure web app for the customer. It's basically the customer facing app. So let us look at our last case study, which is case study 9. In this, we'll talk about a company which is Spotify, which is an iconic global brand for music and podcast. It is delivering customers content. They want to hear an artist's new way to connect with fans and collaborators. So basically, it has 271 million listeners. It has 50 million tracks, 8 plus million per second requests. So further, Spotify brings powerful audio experience to hundreds of millions of people every day. Further, Spotify has continued to innovate its offering while adhering to the enduring principles for growth and sustaining a successful business. So if you see this from the company profile, we come to know that it is a very huge company. So let us see the why this company decided to migrate to cloud. So Spotify's leadership and engineering team agreed that the company's massive in-house data center were difficult to provision and maintain, and they didn't directly serve the company's goal of being the best music service in the world, since they had to store so many music files. It was very difficult to store them and serve them to the users through their own data center. So they wanted to free up the engineers to focus on innovation. They started planning for migration to Google Cloud Platform in 2015, hoping to minimize disruption to product development and minimize the cost and complexity of hybrid operation. So let us see their strategy of migration and what were the results. So Spotify invested 2 years pre-migration in preparing, assigning a dedicated Spotify or Google Cloud migration team to oversee the effort. Ultimately, they split the effort into two parts: service and data. For service migration, engineering team, moved the services to the cloud in 2 weeks. For data migration teams, they were allowed to choose between forklifting or rewriting options to best fit their needs. Ultimately, Spotify's on-premises to begin cloud migration succeeded in increasing scalability while freeing up the developers to innovate. So let us see the key takeaway from this case. So Spotify was careful to consult its engineers about the vision. Once they see what their jobs look like in future, they were all in advocates. So basically, gaining stakeholders buy-in is crucial. Migration preparation shouldn't be rushed. So Spotify's dedicated migration team took the time to investigate various cloud strategies and build out the use cases demonstrating the benefit of cloud computing to the businesses. So basically, they carefully mapped all dependencies. They also worked with Google to identify and orchestrate the right cloud strategy and solution. And finally, focus and dedication, they pay huge dividends. So Spotify's dedicated migration team kept everything on track and in focus, making sure that everyone involved was aware of the past experience and the lessons already learned. In addition, since engineering teams were fully focused on migration effort, they were able to complete it more quickly, thus reducing the disruption to product development. So in this lecture, we have seen 4 case studies. So they have been taken from these sources. The sixth and the seventh case study was taken from Amazon, and the eighth case study was taken from Microsoft Azure's website. And finally, the last case study was taken from Google. Thank you.